Hello, I'm Zan Gregg. I'm a software developer at Jump, which makes statistical discovery software for scientists and engineers. Jump is a subsidiary of SAS, which you may have heard of as a long-time statistical software company. And so though I'm a software developer by trade and maybe an amateur data scientist, I work with a lot of real data scientists, PhD statisticians even, and so I've learned some of their lingo and some of their secrets, and I'm here to share the big secret with you. But first, let me ask if there are any statisticians in the audience. If you're seated next to one, try to hold on to them if they try to cut me off, just in case. Don't think they really have anything to worry about. This is mostly an open secret, at least among statisticians. And you probably already know it yourself, but maybe you haven't realized the gravity of it. So let's get right to it. The secret is related to this line chart. This is called a linear regression or least squares fit, or you may have heard of it just a trend line. Either way, it's a magical line because it's giving you the best fit for that data. No questions asked. There's no fuzzy thing going on like a neural net or something. It's actually a deterministic, optimal, the best line for that data. And I'm sure you've seen it before and you know all about it. But you're probably thinking, not all data fits the requirements to get this line. Don't know what the requirements are. That's what the secret is about. You may think I need continuous data or Gaussian distributed errors, or maybe I need to do a controlled experiment and collect data, or any kind of requirement like that requires a statistician to oversee. But the fact is, you don't need any of that, and that's the secret. The secret is, if you ask for a line, you'll get a line. No questions asked. That's all there is to it. Any data, anybody, anytime. If you ask for a line, you'll get a line. And that's what the software does. That's what the math does. It just doesn't ask questions. It just gives you a line. And I'm sure there's some folks that are thinking, I think I've seen some data that you can't fit a line to. But you're wrong. Any line, any data gives you a line. And so I went through some published journals and collected a few examples just to show the variety of data that you can fit a line to, just by asking. That's all you need to do. So let's get right into it. The first example has unequal variance. You have more spread on one side of the graph than the other. You might think a statistician will tell you that doesn't work. That's not good, but the fact is, if you ask for a line, you'll get a line. Here's an example with not much of a fit at all. It's just a blob of data, but if you ask for a line, you'll get a line. In fact, it doesn't have to have even a slight amount of correlation. If you got no correlation, if you ask for a line, you'll get a line. If you're worried about outliers, no need to worry. If you ask for a line, you'll get a line. What if you got one obvious outlier that's just throwing off the whole thing? No questions. If you ask for a line, you'll get a line. What if your data is obviously not a line? If it's a descending exponential decay kind of situation like this, well, if you ask for a line, you'll get a line. If your data looks like a mountain range, if you ask for a line, you'll get a line. When your data looks like a valley, if you ask for a line, you'll get a line. If your data looks like, say, an anvil, if you ask for a line, you'll get a line. And look at that p-value. I mean, they're really proud of this line. If you have too many data points to even see the pattern in the points, if you ask for a line, you'll get a line. In this particular paper, they also made a box plot version of the same data. And you can see it's not even, it's not even centered around the line, but still, if you ask for a line, you'll get a line. If your data is constrained in has some relationship, like in this case, if you ask for a line, you'll get a line. If your data is mostly in two clumps, if you ask for a line, you'll get a line. If your data is all in two clumps, if you ask for a line, you'll get a line. If your data is mostly in one clump, if you ask for a line, you'll get a line, or in this case, several lines, one line per subgroup. If your data has mostly one x value repeated over and over, if you ask for a line, you'll get a line. If your data has discrete x values, I'm sure a lot of people are worrying about this, but no worries. If you ask for a line, you'll get a line. In fact, if your data has discrete x and y values, if you ask for a line, you'll get a line. If your data cannot be negative, you can still get a line that goes negative. If you ask for a line, you'll get a line. Just not scared by that constraint. Have a negative percent of something. If you put your data on a log scale, if you ask for a line, you'll get a line. If your data is a mix of two different subgroups, if you ask for a line, you'll get a line. If your data is mostly to one side of the X domain, if you ask for a line, you'll get a line. If your data is completely on one side of your X domain, if you ask for a line, you'll get a line. If your data is in two Y clusters, and two clusters in the Y dimension, that is, if you ask for a line, you'll get a line. And finally, a bonus secret, which is a corollary to the main secret. If you ask for a parabola, you'll get a parabola. So that's the secret of data science. Now you know it. You can use it when you're making your own graphs. But most importantly, keep it in mind as you're reading other graphs.